Yes, children. So in today's class, let us see the different types of redox reactions. Okay. Now, what are the different types of redox reactions? See, combination reaction. You know what is combination reaction? You have studied in 10th class, right? Decomposition reaction, displacement reaction, and disproportionation reaction. Regarding this disproportionation, I told you today. Okay. Now, let us see various examples and see how they are also redox reactions. Is there anything which is exceptionally not a redox reaction? That also we will see. Now, combination means what? A plus B giving you AB. Two or more elements combined to give you one single product, that is called as combination. Now look at all these things. C plus O2 CO2, Mg plus N2 Mg3 N2, Fe plus S FeS, Mg plus O2 MgO. Now all these are two or more elements combined to give you one compound. Now CH4 plus O2 giving you CO2 plus water. What do you call this? You call this as a combustion reaction. Now how do you call it as a combination reaction here? That is because whenever two or more elements are combining to give you a single product, this is also called as combination, because out of the two substances which are reacting, if one is in the elemental form, then it can be called as a combination reaction, right? Out of the two substances which are reacting, if one is in the elemental form, it can be called as a combination reaction. That is why, though it is a combustion reaction, it is also considered as a combination reaction. Okay. Now come to the next one, that is decomposition. Okay. Before that, how do you say that they are all redox reactions? Now you see here, C in the elemental form, its oxidation state is 0, and when it becomes CO2, it is plus 4. So there is increase in charge, and O2 it is 0, and here it is minus 2. So there is decrease in charge with respect to oxygen and increase in charge with respect to carbon. So that is what I have shown in each and every reaction. I think you can understand yourself, right? See, I have written everywhere. Now come to the next one, that is decomposition reaction. Now decomposition reaction, what is it? Decomposition reaction means if one particular substance decomposes to give you more than one substance as product, then it is called as decomposition reaction. KClO3 is potassium chlorate. This decomposes to give you potassium chloride and oxygen. Water decomposes to give you hydrogen and oxygen. Now CaCO3 decomposes to give you CaO and CO2. This is of course a decomposition reaction, but this is not a redox reaction. Okay. Now why this is not a redox reaction? Now what is the condition? The condition is all the decomposition reactions are not redox reactions. So what is the condition? The condition is if one of the products of decomposition is in elemental state, then it is considered as a redox reaction. Okay, if one of the product of decomposition is in the elemental state, then only it is called as a redox reaction. Now, what do you find in the case of calcium carbonate? In the case of calcium carbonate, the products formed both are compounds, right? It is not in the elemental state. Neither calcium oxide nor carbon dioxide. Both are compounds. Now, in this case, you see, one is in the compound form and the other one is in the elemental form. Now, in the case of water, both are in the elemental form. So, try to understand the condition. Only those decomposition reactions are redox reactions provided one of the product is in the elemental state. At least one of the product should be in the elemental state. Otherwise, it is not a redox reaction. Right. Now come to the next category, that is displacement reaction. Now this displacement reaction is also of two types. What are they? Metal displacement reaction and non-metal displacement reaction. Metal displacement reaction, you are quite familiar, you have done it in 10th class, so many reactions, is it not? CuSO4 plus zinc gives you zinc sulfate plus copper. Cr2O3 plus Al gives you Al2O3 plus Cr. Cr is chromium. Okay. Now what is the basic condition in these displacement reaction? A more reactive metal displaces a less reactive metal from its salt solution. That is the condition. Okay. So here zinc is a better reducing agent. So it will reduce Cu2 plus to Cu. Same way Al is a better reducing agent. It will reduce Cr3 plus to Cr. Right. So the one which is a stronger reducing agent will reduce the other metal in the ionic form to the corresponding metal. So this is what you call it as metal displacement reaction, because one metal is displacing the other. Zinc is taking the place of copper here, isn't it? पहले copper sulfate था, अब वो zinc sulfate हो गया. Now, what is non-metal displacement reaction? Non-metal displacement reaction means a non-metal is displaced. Now see, sodium plus water gives you NaOH plus hydrogen. Now, how it is a redox reaction? Na is in the 0 state, hydrogen is in the +1 form, and Na has become NaOH, so it is having now +1 state, and hydrogen is in the elemental form, so its oxidation state is 0. So 0 to +1 is oxidation and +1 to 0 is reduction. So this is a redox reaction, right? Okay, now how do you say it is non-metal displacement? Now water, if you consider it, write it as HOH. This is water, is it not? HOH is nothing but water. Now if hydrogen is replaced by Na, displaced by Na, hydrogen is considered as a non-metal. So when non-metal is displaced by a metal, then it is called as non-metal displacement reaction. Same way in the case of Fe also. Though you are not having FeOH thrice, this is also, it is displacing hydrogen from here. And Fe is becoming the oxide. Previously it was hydrogen oxide. Now it has become iron oxide. So it is displacement. So it is not necessary that it should be a metal. It could also be a non-metal. Say for example F2 plus water. F2 plus water is giving you HF plus O2. Now look at the oxidation state. Elemental state, so it is 0. Water O का -2 charge है. HF में F का -1 charge है. And O2 elemental state, so it is 0. So here 0 to -1, that is reduction. -2 to 0, that is oxidation. Okay, so what has happened here? Fluorine displaces oxygen from water. Fluorine is considered to be the strongest oxidizing agent, and it oxidizes water to oxygen. Right? It displaces oxygen from water to elemental oxygen. Same way you can give Cl2 plus KBr gives you KCl plus Br2. Now here what is happening? Cl2 is reacting with Br minus and converting it into Br2. So this is what is actually happening. Cl2 oxidizes Br minus to Br2 and gets itself reduced to Cl minus. This is 0, this is -1, this is -1, this is again 0, right? Cl2 to Cl minus. So this is reduction, and Br minus to Br2, that is oxidation, right? Now generally what we say that the halogens, they oxidize the halide ion which is placed below it in the periodic table. Like if I take F2, this will oxidize Cl minus, Br minus and I minus to their corresponding Cl2, Br2 and I2, और खुद reduce होगा F minus के form में. Same way, if you take Cl2, this will oxidize Br minus to Br2, I minus to I2. Same way, if you take Br2, Br2 will oxidize I minus to I2. Now, iodine के नीचे और कुछ है ही नहीं halogen, ठीक है? So that is the end. And I2 cannot oxidize anything because it is the least oxidizing agent. Okay. So in general, what you understand here, the halogen oxidizes the halide ion which is placed below it in the periodic table. So what is the order? You have F2, fluorine, chlorine, bromine, iodine. This is the order, is it not? So the topmost halogen will oxidize the halide ion which is placed below. Okay. So that is the oxidizing capacity. Now, the fourth category is disproportionation reaction. Fourth category is disproportionation. Now, I told you already what is disproportionation. Disproportionation means one particular species in which a particular atom, it gets oxidized as well as reduced. So here it is H2O2. H2O2 mein, what is this? Hydrogen peroxide. So here this O2 minus, this will be peroxide ion. Now this peroxide ion, it is getting converted into, from the -1 state, it is getting converted to -2 state, and it is also getting converted into O2, that is elemental oxygen. Okay, so here this -1 is the charge of a single oxygen atom. See, whenever I put any number on top, it is the oxidation state of a single atom. Is that clear? Hamesha yaad rakho. H2O2, how do you write? You write like this. This is how you write peroxide. Okay. Now see here, this is +1, this is -1. Again, this is -1, this is +1. So this is a neutral molecule. +1 -1 cancel ho gaya. You will get a neutral molecule, that is H2O2. So what is the oxidation state of oxygen? It is one single oxygen, it is -1. But how do you write peroxide ion? You write peroxide ion as O2, 2 negative. This is called as peroxide. Okay, actually you have O2 minus. This is called as oxide ion. O2 minus is called oxide ion. O2 2 minus is called peroxide ion. And O2 minus is called superoxide ion. Okay, so here it is peroxide. So from -1 state, it is reduced to -2. -2 is less than -1, so it is reduced, and -1 is oxidized to 0. Okay, so this is oxidation, this is reduction. So the same species, that is O, it is getting both oxidized as well as reduced. So it is called as disproportionation. Same way, in the second equation you see Cl2 gives you ClO minus and Cl minus. Now Cl2, it is an element, so the oxidation state is 0. In ClO negative, Cl is having +1. This is +1, this is -2. तभी तो overall charge -1 आ गया, ठीक है ना? और ये -1 है, तो यहाँ 0 to -1, that is reduction. Charge is getting reduced, and 0 to +1, that is oxidation. It is getting oxidized. Okay, so this is called as disproportionation reaction. Now the other one is, other example that I have given is P4 is getting converted to PH3 plus H2 PO2 minus. I think this is what I gave you in the morning also. So here it is 0, here it is -3, and here it is +1. So the same species is getting reduced and it is also getting oxidized. So these are examples for disproportionation reaction.